All right, today we're going to start with hyperbolas. This is the last of the conic sections from Unit 9. Hyperbola is a set of all points in a plane such that the difference of the distances of two fixed points, called the foci, is a given constant. So, again, I'm not going to ask you to know these definitions, but what you are going to need to know is how to apply them and how to draw and graph these hyperbolas. Okay, well, I want to point out a few differences here to you. First, you see a horizontal hyperbola. You notice that the a squared is under the x. There's a minus sign here instead of a plus like with the ellipse, and it equals 1. A hyperbola is two parabolas, basically, looking in a horizontal hyperbola. They point left, they open left and right. We know that it's horizontal because the a squared is under the x squared and the b squared is under the y squared. So then we're going to move up and we're going to look at a vertical hyperbola. I'm going to move this up. And the standard form for the vertical hyperbola, as we move it up, looks just the same, except, again, there's a minus sign between. Vertical means that they're going to point up and down. There's always two. Now look where the A is. The A is listed first, just like it was in the horizontal, but it's under the y squared. That's how you know that it's vertical versus horizontal. If this was an x here, it would be a horizontal hyperbola. You're going to read h and k from the formula, just like you had done for the past 4 sessions. To find c squared, this is a little different. To find c squared in the ellipse, it was a squared minus b squared. To find c squared with the hyperbola, it's a squared plus b squared. So we're going to do some applications of this and work a few of them out. And always, the other thing, if you notice at the bottom of your notes, in the hyperbola, the a squared is always listed first. In the ellipse, the a squared was always the biggest. So it's different. That's another thing that's different with an ellipse. The formula looks very similar to that of an ellipse. So you have to be careful not to get them confused. All right, let's move on to the next page. Going to page 2. All right, we're going to work problem 1 first. So let's get our pen. The first thing you need to decide is if this is a horizontal or a vertical hyperbola. Well, the a is always first, and it is under the x squared. So it is a horizontal hyperbola. It will point left and right. Okay. The center is 2, 3. It's a point. So we'll go over here to 2, 3 and put our point. Okay. A is the square root of a squared, so that's 3. And b is 5. Now notice in this case the b is the biggest one. Again, different from an ellipse. The b can be bigger than a. A is always listed first. C squared is a squared plus b squared, which is 34. So C is going to be the square root of 34, or an estimated value of 5.8. Okay? So C is about 5.8. All right, so now, this is how you'd go about drawing these things. Remember, A goes in the direction the horizontal, the hyperbola is. So it's horizontal. So A are going to be the ones that you move here. This is your center. Your vertices are going to be right here and 3 to the left right here. So the vertices are at 1, 2, 3, 4, 5, 3, and at -1, 3. The foci will be 5.8 along that same axis, So from the center, so you're going to go 1, 2, 3, 4, 5, almost 6 will be one focus here. And from the center, 1, 2, 3, 4, 5, almost 6 will be one focus here. All right, so the points, the coordinates of the focus are 1, 2, 3, 4, 5, 6, 7.8. Should be a decimal place. 3 and at negative 3.8. 3. All right, so we've got our center, our vertex, and our focus all along the horizontal axis because it's a horizontal hyperbola. Now we have to draw the hyperbola. So to do that, we need to go up and down B spaces. 1, 2, 3, 4, 5 from the center. 1, 2, 3, 4, 5 from the center. Now the way to draw this is you sketch in a box including these vertices, okay, and going through these coordinates where B is going to meet, so you kind of sketch in this box, okay. Now with a ruler, and I don't have a ruler, wish I did. Let's see if I can get, there's one in the toolbox. Doesn't look like it. That would be nice, but it doesn't look like there is. I was thinking there was a freehand. Guess not. I don't want the timer. What I want is let's see, Scalary. Okay, no, that's not what I want. What I want's not here. Okay. All right, well, let's get out of these. Okay. What you're going to do is you're going to take a ruler and you're going to draw a line, and I want you to dash it. Okay. And my line, obviously, since it's freehanded, is not going to be good. From each corner diagonally through the center, okay, here, and then from this corner diagonally go through the center and through the other corner. And pitiful line, I know. Okay, so you're going to draw that. Then you're going to take from your vertex and you're going to sketch going outward toward the diagonal your hyperbola. You're going to go from the vertex here outward toward the diagonal and get a hyperbola. Okay, so you're going to come down here through the vertex, go back out, don't go through that box, and get your hyperbola. Okay, so there's your left and right hyperbola. All right. Now, let's go do example 2 and 3, and this markings are all going to go away when I do this. And I'm going to move this over so it's not in the way of the drawing. Move this up and see if we can get all of it on there. No, we can't. We'll have to do 2 and then 3. Okay, so horizontal or vertical? This one is vertical because under there's the 4A is under the Y, so A is 2, B is 4. The center X goes first, so it's -2, 1. Okay, but now we're going to go up and down with from the center along our axes. So we mark at -2, 1, our center. This is our center. Our vertex is going to be 2 spaces away, up and down. And our focus, we have to figure out on the focus how far that's going to be. Remember, c squared is equal to a squared plus b squared. So that's 20. So c is the square root of 20, or it's about 4.5. So c is 4.5. So we go along this same line from the center, 1, 2, 3, 4.5, and that's a focus point. And from the center, 1, 2, 3, 4.5, and that's another focus point. Okay. Now we need to try to draw our box in. And so I'm going to see if I can just do a dash here. We'll try to do it with dots. First we need to go, and for our B is 4 spaces to the left. 1, 2, 3, 4. And 1, 2, 3, 4 spaces here. Okay. And now we're going to go on the vertex. We're going to draw our box here around through the vertex and the other axis. Okay. All right, we've got that. Now we're going to try to draw a dashed line. So I'm going to go back here to my style and try to just draw a dashed line. And I'm going to see if I can, if it'll make it straight. We're going to hope. That's not going to work. That's not what I want. Okay, I want the line type right here. All right, we're going to, I don't want that off. I want this. That's what I want right there. Okay, dashes. We're going to go right here, ignore that, and we're going to go through the center. Again, you're going to get a ruler to do this so it doesn't look like my line trying to do freehand. We're going to go through the center, okay, like that. Now we want to draw our hyperbola, and I'm going to change the color just so it looks like we can see a different color. And it's going to be a solid line. Now remember, it's up and down, so this is our vertex, and we're going to go out to the dashed line here, go around. It looks like a hyperbola, like a parabola, each one. Go out to the dashed line and do that down here. Pull it out towards the dashed line and pull this and curve it out towards the dashed line. Okay, so that is your vertical hyperbola. Now we're going to do our last example. I'm going to go back and get black again. I'm going to change it to the mouse so I can pull down to my last example. All right. What is this one? Is it vertical or horizontal? We look. Now remember, if this happens to be a plus, you better catch that because that'll be an ellipse. This is a hyperbola, but there's on your homework you could throw in an ellipse. Under the X, so A is 3, B is 2, the center is -1, 3. Okay. So since the A is under the X, it's a horizontal hyperbola. So at -1, 3, we make a point. And we mark left and right, 3 spaces, 1, 2, 3, and 1, 2, 3. And we can go ahead and mark up and down if we want to, or B. So the vertices are these. And so the vertices are at 2, 3, and at -4, 3. And I think I forgot to mark the foci points before, but we need to figure the foci c² is equal to 9 plus 4, which is 13. So C will be the square root of 13, which is about 3.6. So 3.6, okay, we have the focus. So we're going to go here along the axis where we have our vertices, and 1, 2, 3.6, just barely past that, and then here 1, 2, 3.6 right there are our two focus. So our focus is out here, our vertex is just inside of that. Alright, so the focus points are 2.6, 3, and negative 4.6, 3. Right. So we're going to draw our box. The only reason you draw your box is to help you locate your diagonals. So we're going to go through the vertex there, through this minor axis, and then up through this vertex here. So we've got our box sort of sketched in. Now we're going to draw the dashed lines for our diagonals. So we're going to go just make a X, go through the center there. We're going to go through this corner, through the center, and through that corner, and you're going to do it with a ruler so it's straight. All right, so there's your guidelines. Now we're going to go here and we're going to draw the hyperbola. We'll put in, make this one hot pink, why not? All right, so we're going to go and make it bigger. What the heck? All right, so you're going to start at your vertex and you're going to go up and pull it towards the diagonal. And pull it towards the diagonal, and you'll notice this one is maybe a little more curved, not as wide. Pull this towards the diagonal, and this towards the diagonal. Okay, and that's your hyperbola for the example number 3. So I'm going to have one more lesson today, and then you're going to work on your homework.